All right, cool. Hi, everyone, and welcome to our session today on Compose Multiplatform. Before we get into this, I'd just like to see a tiny little show of hands while hopefully our own slides go up on the big screen. Thank you very much. How many of you folks have an Android background? Just a quick raise of hands. Cool. Great. That means we can skip a Kotlin introduction for the most part. But just to do the counterpart of this, who here has an iOS background? Hey, look at that. That's wonderful. And who here has been developing cross-platform? Wonderful. What a mixed crowd. That's so delightful. Yeah. So today we're going to talk about Compose Multiplatform, and we'll see how this little framework that we've been building at JetBrains equips you with new superpowers when it comes to building multi-platform applications. There's a bunch of different things that we want to go through today, and we're pretty short on time, so we're going to dive in pretty quickly. We're going to give a brief overview of what Compose Multiplatform is as a framework. We're going to look at the different targets of Compose Multiplatform and their stability. Then we'll get to the meat of the entire talk, which is going to be our live demo, where we will start from essentially zero, and we will build a small application live on stage using nothing but our wits and the power of these two laptops. After that, we will also talk a little bit about interop with the individual platforms. We will take a look at the ecosystem and what that looks like, and hopefully get a bit of an outlook. And so by the end of this entire talk, we will have built a very small, simple app that runs on desktop, on Android, iOS, and potentially even beyond. That'll just consume some data from an API, in this case, a couple of images. We'll show it and will allow us to kind of navigate between different categories. But before that, it's probably good that we really see what we're even building on here.
All right, so before we get to Compose Multiplatform, let's have a bit of an overview of how Kotlin Multiplatform can be used to share things in your applications. Here we have an example where we are building two mobile applications for iOS and Android, and we have a shared layer of business logic in there in the middle, which is using Kotlin Multiplatform and then compiling that Kotlin code to native on each side. And so far, at least, we have two independent UI implementations built on top of this. On the iOS side with SwiftUI and/or UIKit, and on the Android side with Jetpack Compose. So this duplication of UI that we have at the moment with two implementations is what we're looking to solve with Compose Multiplatform. Compose Multiplatform is a UI framework by JetBrains, which allows you to write UI in Kotlin code and then compile it to multiple platforms. This is all built on top of Kotlin Multiplatform. This is an extension of Google's Jetpack Compose, which allows you to write UI on Android, but this time you get to do it for all the platforms. More specifically, these are our supported platforms. So on iOS, this is currently in alpha. On Android, when you use Compose Multiplatform, it's really just using Jetpack Compose, so that's stable. On desktop, this is also already stable. In fact, we have more than 1 million users just on the Toolbox app alone, which is powered by Compose on desktop. And finally, we also have support for web, which is currently experimental. So if we add Compose Multiplatform to this diagram that we had before, we can actually also have a shared UI layer like this, so that we write the UI once as well. And it's important to note that this is not an all or nothing proposition either. You get to choose which parts of your UI you want to share with Compose Multiplatform, and you can also interop with the native views of each platform if you wish. And because we're not just targeting iOS and Android with Kotlin Multiplatform and with Compose Multiplatform, you can also fairly easily add additional targets at this point. For example, if you also wanted to build a desktop application, you could share essentially the same code there as well. If you're coming from an Android background, which a lot of you are apparently, then knowing Jetpack Compose already is a huge advantage to using Compose Multiplatform, because almost all of the APIs are the same. So any existing knowledge you have with Jetpack Compose, you're going to be able to reuse that with Compose Multiplatform. And the same goes for the materials that you can use to learn about multiplatform, about Compose. You can use our documentation on the Kotlin Multiplatform development portal, which tells you a lot about Kotlin Multiplatform, Compose Multiplatform, and the accompanying tooling. And you can also use documentation that's written for Jetpack Compose. For example, all of Google's documentation about the foundations of the framework, how state management works, and so on. And that brings us back to our application today.
Yeah. Because obviously it's always nice to talk about, yeah, the APIs are the same, or yeah, you should be able to quite easily understand the code that's going on. We very much like putting our money where our mouth is here and actually showing you a little bit of this. So we are going to switch over to our IDE in just a second. Just as a quick overview conceptually about what we're going to build here, we're going to have some kind of JSON backend that will just send us some information. We'll consume those in a view model that we'll write in Kotlin, and then we have a very simple UI. So we'll have some sort of column structure, then we have a row of buttons that specify individual categories, in our case of little bird images, and then we'll have this scrollable grid at the bottom that shows a couple of different things. Now, of course, just doing a live demo wouldn't be enough for us. We're always trying to go the extra mile here a little bit. So we're not just going to do this on one machine or just one of us, but instead we are going to use JetBrains' new multi-platform IDE, JetBrains Fleet. And not only are we going to do that, we are also going to use its built-in collaboration mode. Which means that the two laptops that you will see here, we will be working on simultaneously. So you will constantly be seeing my screen, but you will also be seeing Márton's cursor zipping around the code base, and we will follow him along as we do things. But everything will be running entirely on my machine, and we'll just collaborate here. Okay, so the first obvious question is, how would you start out with a new project in Kotlin Multiplatform? And the answer for that is you can go to kmp.jetbrains.com, and we have a wonderful little wizard that takes you already pretty far. You can just enter a project name. In our case, that will be maybe my bird app, because I already filled this out prior. I already have my ID set in here. And then we can just pick and choose our different platforms. Android seems like an obvious one, as does iOS. We can either do just business logic sharing, or we can do shared UIs as well. And in our case, we would probably also pick desktop. As you can see, we also have support for the experimental web target, and you can also add server right here. From there, it's a matter of just pressing a single button, hitting the download button, and getting a zip file that we can then open. So once we open this in our IDE, what we will see, I've just done this so we can skip over a couple of loading times. This is Fleet, in case you haven't seen Fleet before. Welcome. This is one of the pre-release builds, so please cross your fingers so that everything will go well. The first thing that you will see when you open it is that it actually checks and makes sure that the entire setup of your development environment is correct for multi-platform. So make sure we have the right Java, the right Android SDKs going on, that Xcode is set up properly so that we can run all of these applications. And from here, we can just go into one of the run configurations. We see that it's available for all the platforms, and we could run it, for example, on desktop, and we get a little scaffolding application with just a click me button that shows us this little logo with an animation, and it also gives us some information about the target that we're running on. Pretty boring so far. This is not exactly the app that's going to dominate the charts of any app store. So it's time for us to add a little bit of business logic. The backend that we have here is, as I said before, just a very simple JSON kind of array that we'll be able to consume, which just has a couple of fields. We have a category, so we have a couple of images of pigeons, eagles, and owls, and then it also has a path and an author. If we follow the path, we get to the actual image. Okay, cool. So we know what we have. Now it's time we lay the foundation on how to actually get that into our app. Márton, how would we do that? What do we need?
Yeah, for this part, we're going to need a couple dependencies, which I'm going to be able to show you by my cursor hopping around here. So we've already added 3 different dependencies to our project. All of these are dependencies that are under common main, which means that they are available for multi-platform, and we can just write shared Kotlin code, and these will do platform-specific implementations in the background for us as needed. The 3 dependencies we've added are Ktor, which is our very own networking library for Kotlin Multiplatform. Here we're using the client part of Ktor because we need to access some data from this JSON. Then we've added Coil, which is originally an image loading library for Android, but it has actually started going multi-platform in its latest builds and latest version. So we're going to be able to use that to load image data. And finally, we have added the Android X view model library here, which has also been recently ported so that we can use it in multi-platform. So we're going to be able to create a view model to do our data loading.
Wonderful. And I think that's exactly what we can do right now. So we can just move in. And probably before that, what would make sense would be to first have some sort of data model, right? So what we'll do here is we'll just, give me 2 seconds here, create ourselves a little just class that we will be able to use for serialization, right? The classic case of just bringing in some JSON and turning it into a serializable class. Typically, I suppose what you could just do is type this out or try to match these manually. I'm just going to invoke AI Assistant with this JSON and see if it can come up with something that seems somewhat reasonable.
If we can get through the Wi-Fi, this is going to be great.
Oh, and it even gives me an example. That's wonderful. I won't need the example, so I can just accept this and get rid of this individual example. But now we have our serializable data class. Wonderful. And we can move straight on to actually building our view model. So we'll have our birds view model. We'll have that here. That's a class. And then again, if you're from the Android background, this should not be surprising to you at all. We can just have, we can just inherit from the view model class, and we can kind of start writing some code here. I think the most basic part we need is some sort of HTTP client. So I'm just going to do that by briefly creating one with Ktor. Most configuration of this is already being automatically picked up. The only part that I need to provide is the fact that we need content negotiation with JSON. With that out of the way, all that I can essentially build is a getImages function. And I know that that is supposed to return me a list of these bird image objects. Great, that's one parenthesis too many, my bad. And everything we can pretty much do in here is we can just say, OK, return from my HTTP client, make a GET request to this specific endpoint. And then, by the way, if someone can't see the code, please just shout out. It's hard to manage these things all at the same time. And then we'll just say, give me the body of this. This still doesn't work so far because this is a suspending function. But of course, we can just make the function suspend. And then that entire thing just works. Cool, great. So from here, I think it would make sense to maybe also do a little bit of state management, right?
Yeah, so we have a function that can fetch our data. Let's now actually store this somewhere in the view model so that we can then observe it from the UI and actually present it to the user on the screen. First, because we are in a view model, we have, again, access to usual APIs like the onClear function. Here, for example, we can use this to grab our HTTP client and shut it down. Is it a stop function? It's a close function. There we go. And shut it down so that whenever the view model is cleared, we can finish any still pending requests. Then we want to create that UI state. We can make this a quick data class. We're going to call this a birds UI state. And for now, all we need to store is a list of these bird images. So that's going to be an images property. Its type is list of bird image. And we can just make that an empty list for starters. Then we want to store an instance of this inside the view model, and we can use state flows for this. So I'll create a UI state property. That's going to be a mutable state flow. And in there, we're going to put an initial instance of the birds UI state, just like that. And because this is the private mutable version, we also want a publicly observable one. So that's going to be just called UI state. And we'll just grab our private property and convert it to a regular stateflow type. And we have the nice parameter hints enabled there. So you can all see that as well. And from here, going back again to the getImages function that's already implemented, we can create a function that we can call on the view model and do that data loading. So we're going to call that updateImages. And in there, we're going to use the view model scope API, which again is the same API that you can use on Android. In there, we can launch a coroutine We're going to load the images using the function we already have. And then we'll grab the UI state, issue an update on it. And in the update, we'll just take the existing UI state. Let's actually name that. And we'll copy it, and we'll override the images with what we have just acquired from the network. And I think with that, we have a working view model set up.
Well, of course, I trust you on that, but for me, seeing is always better than is believing. So what I'm going to do is I'm going to throw out a little bit of the scaffolding code that was in the original app, and I'm just going to add maybe a text component here where I'll display this kind of stuff. For that, of course, I need to have an implementation of that view model. So I will just grab myself probably a better name would be birds view model, just to make that sure, equals view model, and then we just construct that one right here. We should probably then just grab ourselves this view model's state. We probably are not going to do that right in here. Instead, we are just going to have that out here. This is why I really love inlay hints, because I keep on forgetting that we also have these wonderful delegates. So instead of having a state flow, I can just type by and then hopefully get my collect as state implementation. And all of a sudden, this is my birds UI state that I can access. So in this case, it would be my images, and I'd put that up as toString. Sound good to you?
Sounds decent. Of course, this is going to be a huge JSON string here, so we can really easily pop in a modifier here to make it scrollable. So that would be vertical scroll, and I think we just need a remember scroll state call in there. And I think that we should be able to run.
Cool. Well, with that out of the way, and now that it's scrollable, I feel confident putting this up on our Android emulator this time rather than on desktop. So we'll have a look here.
You know what we haven't done yet? We haven't called the update image function.
Interesting.
So let's also do that.
Huh. See, now the great part is I can distract you while Márton types. That's the power of collaborative editing.
So what we'll actually do here is use a launched effect. We can key this to the view model. Not that instance is ever going to change, but this is the decent way to do it. And we can just call update images in that launched effect, which will actually initialize the view model.
Beautiful. Do you want to rerun the app? Or?
Of course. Are we doing Android?
Sure.
Yeah. There you go.
Wonderful.
On Android.
Great. We'll give this a second. I hope. Let's try that one more time.
Is your emulator running?
It probably is. Probably just give that a quick little restart. Why not?
In the meantime, we can run this on desktop.
Oh, yeah.
To see that our code works.
OK, so we definitely see some text, and it is scrollable. And now let's maybe have a look and see if we can get it also running on Android. After all, it is just Jetpack Compose on Android. Give it a second. Give it a second.
There we go.
Hey, look at that. Wonderful. By the way, those of you always also thinking in like error conditions and such, I mean, you've probably noticed that we're not catching any exceptions and stuff. So the moment the network goes out on us, our apps just start crashing. Don't do that in production. It just, again, it heightens the thrill of being on stage when you do it that way. Plus, it keeps us from writing 7 more lines. OK, cool. Great. Well, it doesn't look, once again, not exactly App Store top 100 just yet. Maybe a little more work might be required here. Yeah. So what could we do there?
Yeah. So let's get rid of the text that we've been displaying and start writing some actual UI like we've seen on the screenshots in the beginning. Let's imagine that we'll have a birds page, which actually displays the UI. And let's grab our UI state that we've extracted here. Then we're going to create this as a new composable function down here. And let's start implementing that. So as you hopefully remember, we're going to have a row of buttons on the top and then a grid of images below. For now, I'll just create an empty row here, and we'll fill that out later for the categories. First, we want to make sure that we can do the image loading correctly. So we're going to create an a lazy grid for that. But to make this nice and animated, we're also going to wrap it into an animated visibility. And we'll want this to be visible if the UI states images is not empty. And in there, again, we're going to do the grid. So it's going to be a lazy vertical grid specifically. We can give that a column specification. We can use adaptive columns here. And we can specify that we want each column to be at least 180 dps, which we happen to know is a nice amount for this demo. And I think that's essentially what we need for a start here. We can make this pretty later, but it will work for a start. Then we'll fill this with items. So we'll just go through the UI states images, and for each of those that's a typo. So for each of those images, we'll want to display it, and we can do that with another composable that we'll make up here. So we're going to call that a bird image cell, and send the image into it as a parameter.
So in case you haven't picked up on yet, by the way, while you can't see it, Márton gets full autocomplete intentions and so on his machine as well.
Yeah. So at this point, we're going to use the call library to do the image loading part. So I'll create an async image here. For which we'll need, first of all, the model, which would be the URL that Seb can hopefully help me with. And while he does that, I'll fill out some other fields. For example, I'll create a nice content description for accessibility here, because it is a demo, but we still want to provide that parameter nicely. For example, we can say category by author here. And then we want square images here, and we want some cropping on it. So the content scale here should be content scale crop. And of course, I need to import that. Again, you don't see all of the pop-ups here, but I have a full UI version running here. And then we'll just add a modifier to make sure that these are squares indeed. So that's going to be an aspect ratio modifier. We can make that 1. And we can make sure that the images fill the width available in the grid. So that's going to be a fill max width modifier. And I think with that, we can probably run that.
Cool. What do you want to run it
on? Let's run it on iOS.
OK, sure. That sounds good. Let's give it a try. Let's have a look. Move this one over here. It's always delightful when there's a couple of warnings bubbling up. And look at that. We have a grid running on iOS. Beautiful.
It's birds.
Yeah, it is birds.
Thank you to the one person who was clapping.
Hey! Yeah, what you also notice here, those of you who are using an iPhone, we have the same kind of scroll physics that you might be expecting. So you have a nice little like overscroll effect, all these kind of things. And of course, on the other platforms, those would behave exactly like the platform that you would expect. I think this could still be made just slightly nicer, right?
Yeah, I think you can just rerun the app, because I've also filled in some spacing and some padding settings as you were showing that off.
Look at that. Isn't that magic? It really saves a lot of time when you just have someone else doing the work for you.
It's also a good idea to run this on desktop, which I
mean, you can do that if you want to. I'm just gonna keep my hands away.
I'm gonna stop and rerun the desktop app.
Yeah, look at that.
Yep.
No hands, and we have.
And because we have an adaptive grid here, if you just resize the desktop app a little, we should see that we get a dynamic number of columns.
Beautiful. Look at that. Wonderfully responsive. Now I think we're like top 500 already. Not top 100, but top 500. I think what's missing, or one of the issues, is still that we have all of these different types of birds. We got some pigeons, we got some owls, we got some eagles, but they're all on the same page. So I think what would be a lot nicer would be building something that would allow us to filter that, like we saw in the beginning. And the best part, of course, is that I kind of already have a little bit of the scaffolding in place, so I can just imagine that some certain APIs would exist, right? And then probably from there, I could build something, right? So for example, I could say for category in my UI states categories, categories. For each of those, I'd probably want to have some sort of button. That button has an on-click. We'd probably bubble that up because it's probably not the task of the bird's page to handle this. So we'll just have an on-select category up here, which is a string to unit, and that will probably update some internal state. So once again, in this case, what we would just do is on select category with that specific string. What's still left then is actually giving this some sort of label. So this would just once again be our category. And hopefully, I mean, we could probably make this a little bit more beautiful. So we could add something like a modifier where we give this a, first of all, weight of 1.0f and then an aspect ratio of 1.0f as well. Great. Now you can take a brief look at this. And of course, this is supposed to be category, which should resolve that problem just fine. I'm not sure why I'm still expecting an expression here.
I think you're just missing a parameter up high. No, I think you're good.
OK, cool, great. So one of the parts that you probably noticed is that while I was doing this, the categories thing turned from red to purple. Márton, what's up with that?
Yeah, so if we hop over to the view model side, in the meantime, I have updated our bird's UI state a bit. Previously, we only had a list of images, but now we'll also want to keep track of the currently selected category, which we have saved here as a nullable string. And then for convenience, we have two filtered views of the data inside the UI state. So we have a categories, which is just all of the different unique category strings in our data. And then we have a selected images list, which is the images that are in the selected category. And we also want to actually change this over time in our view model. So if we scroll down, we'll find the the select category function there, which we can call it a category. And this again makes an update to the UI state. If the category was already selected, it just clears the selection. Otherwise, it makes that category the selected category.
Cool, great. Now this function, I guess we haven't really used up here yet, right? That's what we were seeing up here, and that was what was giving us a little bit of grief. So in this case, our onSelect category would just go into our bird's view model and, well, select that specific category. And I hope that this would work. IDE is giving us a little bit of trouble here, but we'll just have a look and see if it does work. Look at that. We do have our categories. We got our eagles. We got, hopefully, our owls.
The thing is, we're not using the selected images yet.
Oh, look at that. Great.
So if we hop down here.
Once again, that's the beauty of having more than one person being able to work on things.
If we hop down here, we can make sure that both for the visibility of the grid and for the actual images that we're putting into the grid, we're using selected images instead of images.
Yeah, cool. So let's run that again real briefly. And now we have our categories with eagle, owls, and pigeons. Wonderful. And of course, this would also work on our other platforms. But before we get into that, I think this is still obviously very material designy. We get these like little paper style indicators for interactions and the like. We could probably do a little bit of styling before we run our app for the final time here.
Yeah, and as you already said, all of this is material themed. If we take a look at the app code, all of it is wrapped in a material theme here. But we, of course, get to customize that. So up here, I've created a bird app theme composable function, which uses material theme as well, and then places whatever content we pass to it inside that theme. But we are customizing a couple things here. So we're going to use black as our base color here as the primary color. And we'll also get rid of some of the rounded shapes that material comes with. And we can essentially just drop down here, and instead of material theme, we can just use bird app theme to wrap our application. And with that, we should be able to rerun that on all of our platforms.
Cool, wonderful. So let's run that on iOS, let's run that on our Android emulator, and let's also run it on desktop just for, whoops, that's the iOS one, on desktop.
I've already started it on desktop as well. Sorry.
It's always the same, always the same. We sometimes do live coding streams. It's mainly just me talking to the audience and him typing into my Fleet instance. It's great. Check it out sometime. Yeah, and now we have something that's a little more subtle, you know, that has a little blockier look, that might feel a little more natural across multiple platforms. And of course, you can adjust that as you see fit with the entire configuration. Did you rerun the Android one as well?
I did not.
Okay. Oh, that's our Android emulator once again, wonderfully hanging. Beautiful, but we're not stopping now. That's for sure. Nothing will take this part from me.
There we go.
Beautiful. So we have Android, we have iOS, and we have desktop. Cool, sweet. So with that, we can move on and we can take just a quick little recap and dive into a couple of things, for as long as we still have time. We saw how to create an entirely new project using our Kotlin Multiplatform wizards. We saw that your entire development setup gets automatically checked by Fleet, which is currently in preview and that you can already try out. We used a couple of multi-platform libraries, very subtle, but again, the beautiful thing is in a lot of parts, you didn't even have to really care about it. We built the entire UI in Compose Multiplatform. You never saw us touch any code that wasn't Kotlin, which is quite exciting. And we deployed it to iOS, to Android, and to desktop in this case. Couple of points that usually come up as the typical question. Whenever you build an app for an operating system, you usually want to use the capabilities of those operating systems. Of course, on Android, you get full access because it's just Jetpack Compose. On iOS, we provide interoperability in both ways. So you can both include things like an Apple map, for example, within your Compose UI. We just have adapter functions that allow you to do that. Or you can throw up a camera feed and put some Compose buttons on top of that. Alternatively, you can also gradually adopt Compose Multiplatform. So in this case over here, for example, we have a tab bar that comes out of Swift UI. But for example, the entire chat window itself, that's rendered in Compose. Even with a floating Swift UI text field on top, works perfectly as you would expect. The on-screen keyboards don't give you any trouble and the like. So Compose Multiplatform does build on Kotlin Multiplatform, which is worth reiterating once more. It's fully native on Android, and on iOS you're getting Kotlin native binaries, so you're getting super comparable performance to any other way of targeting iOS. It also means that there is no magic switch, because there's not like a magic emulation translation layer that's happening. This transition kind of takes a little bit of work. If you, for example, need to provide platform-specific implementations, Kotlin Multiplatform has this built in as a first-class language concept. They're called expect actual functions, where, for example, you could say, hey, I'm looking for an implementation of the function getPlatform that returns me a string, but I don't know what that will be on the individual platforms. And then on each individual platform, you can provide an implementation that actually uses those that platform-specific capabilities, whether that's UI device, system get property, or something from the Android SDK.
Of course, you don't want to do that all the time. You don't want to build these bridges to platform-specific implementations yourself for everything. So luckily, we have a really nice, healthy ecosystem and a growing number of Kotlin multiplatform libraries that you can make use of. This includes some libraries from the Jetpack side. Google has started multiplatformizing some of their libraries a while back at this point. So you can check all of those out and reuse them for multi-platform. We have also just created a multi-platform implementation of the Jetpack Compose navigation library, the navigation component. So you can use that in common code as well. This time in our demo, we had a single screen, but otherwise we could have shown you this. And this, of course, is, again, something that can be familiar to you from the Android side. And if you have an existing Android application, it can make it easier to bring it to multiple platforms. And this joins really nice community-created navigation libraries, which also exist for Compose Multiplatform in multiple flavors. We also have a solution for you to share resources with Compose Multiplatform. This, again, is quite similar to the Android resource system. You can share values, drawables, fonts, and files at the moment. You have qualifier support. You have type-safe accessors generated for you, and so on. We also have image loading. We've seen this in the demo, not just Coil, which is a relatively new multi-platform library, but also other libraries in the ecosystem. We can also talk about theming quickly here. We ship with Material by default, just like Jetpack Compose, but there are also community projects which provide theming for Compose Multiplatform. For example, there is this Cupertino theming project, which gives you iOS-style widgets. Going beyond the UI layer, there are great libraries for data access on Kotlin Multiplatform. We have networking libraries. You've seen Ktor being demoed. That's also a server-side library. And we have libraries like KTorFit, which allow you to have a higher level API on top of Ktor. A lot of options for persistence as well, whether you want to have structured storage and store large pieces of data. You have libraries like SQLite and KStore. If you need to store key value pairs, you have libraries like DataStore and multi-platform settings. And in general, if you're looking to solve a problem for multi-platform, you can always go to the KMP Awesome repository on GitHub and find a huge list of multi-platform libraries for logging, testing, date, time, serialization, and essentially anything. Something really nice about Compose multi-platform libraries is that they are fully backwards compatible with Jetpack Compose. So if you're looking at a Compose multi-platform library, you can use that in a multi-platform project, or you can also just use that library in a Jetpack Compose project that's only being compiled for Android.
Yeah, and that's pretty much also our CTA at this point. If you are an app developer, we'd love for you to go and try Compose Multiplatform, whether that's on iOS, together with Android, desktop, or even beyond that. Maybe even try the WebAssembly target. Who knows? If you're a library developer, it would be awesome to see how much work maybe it would take for you to support multi-platform, because you can reach an even wider audience and just an even wider range of devices that people might be using. For your own explorations, we have a ton of different sample applications that are available on our official repositories, as well as in our documentation. A couple of these screenshots you already saw, but there's even more complex ones available there as well. The entry point to the entire Compose multi-platform universe can be found on jb.gg/compose, which brings you to our landing page. And of course, if you're looking for other like-minded people, you're always welcome in the Compose multi-platform related channels on the Kotlin Lang Slack, where you find a lot of people doing great stuff. Cool. We somehow, even though with a couple of hiccups, managed to actually hit our time frame pretty well. I'm quite happy about that. So yeah, thank you so much for coming here. Thank you so much for your attention. And we do hope you will try and enjoy Compose multi-platform yourself. Thank you.
Thank you.